This question asks, based on the specific reaction below, which of the following statements below is false? So we basically have a true-false question, but it's very centered on the mechanism of the reaction. So if you look at some of our answer choices by previewing them a bit, the first one asks the first step is a proton transfer, or one of the key intermediates is an alcohol. So we really have to think about the mechanism of this reaction in order to answer our true-false question. So first up, let's take a look at what we've got. We have an ether reacting with excess HBr. So this is essentially acidic cleavage. And so we're going to work through the mechanism together and then use that mechanism to answer our true-false questions. First thing we're going to do is draw the first step. We have a very strong acid. So the first step of this reaction is indeed proton transfer. So we can say that, yes, that one is true. Next, let's think about what our product would be from this very first step. We're going to protonate that oxygen and it'll have a plus charge. And so we have this intermediate. The bromide that we kicked off in the previous step is going to come in and undergo an SN2 reaction. So that's going to kick off an alcohol. And we're going to make an alkyl halide, or specifically an alkyl bromide. So these are kind of the intermediates of this reaction. We can see right away that one of the key intermediates is an alcohol. And so we're kind of already answering questions as we work through this mechanism. Next, let's see what would happen in kind of the second stage of this reaction. Again, we have HBr reacting because we have excess. And now we have a tertiary alcohol. And so the tricky part here is thinking about how does tertiary alcohol react with HBr? And if you can kind of remember back to when we talked about alcohols reacting with strong acids, the first thing that will happen is proton transfer again. And we're going to make this molecule that has a very good leaving group attached to it. So we will see here loss of a leaving group to form a carbocation. And then the bromide will come in and attack. So this is an SN1-like reaction. We make this alkyl bromide, and we have water as our byproduct. So B is also true. The mechanism involves both SN2 and SN1 substitution. We did SN2 kind of in this first phase of the reaction, and then SN1 here in the second phase of the reaction. Next, let's kind of take a look at answer choice C. Answer choice C says we're going to make two different alkyl halides, and that is correct. We make a tertiary alkyl halide and a primary alkyl halide. So we've kind of narrowed our choices down, and the only answer left is E. The oxygen of the ether starting material, and I'm going to highlight it up here in orange, is going to end up as the oxygen of an alcohol byproduct at the end of the reaction. So let's kind of track as we move through where the oxygen is in each instance. Okay, and what we find is that the oxygen of the ether ends up in water, which is not technically an alcohol with an alkyl group attached to it. So I would say here that E is the only answer choice that is false, because the oxygen ends up in water instead of, say, like an alcohol that we would make, which we don't actually make in this reaction. We're making alkyl halides. So answer choice E is the false statement.